Let's solve this problem using the example given here. So I will choose this nums array and let me put it here somewhere. Okay, so just mark the index as say I. Nums I 10, 9, 2, 5. Okay, and index can be also marked. So this is the array which we are taking as an example to solve this problem. Okay. Now let me also mark our DP solution for each index, which is LIS, longest increasing subsequence. So if I just start with the last index first, the number of 18. Now for just for this 18 array containing only one element of 18, there is always a possibility of having a sequence of length 1 only, which is 18 itself. And there is no next element or previous element. So we can always say that our base condition or the longest increasing subsequence for the last array element is always going to be 1. And it's going to be same for all the elements. For example, it's not only the last element. For example, if I just choose one element 101 or just 7 or just 3, all of them would be having at least a subsequence of 1 without any order. So by default, I mean, this is the base condition that for each of the array element on its own, the LIS for that particular index containing only that element will always be 1. So let me mark for each of the index here. So LIS 7 is 1. Now let's go to LIS 6, which is 101. Now suppose I just take these two elements as an array. Now again, 101 on its own is having 1, a length LIS of 1 if we just take this one. Now if we want to include the second element here, we need to check because it's always has to be in the increasing order. Now if we check that LIS of 101 is less than 18, it means that we cannot take both of these elements in our subsequence because the ordering is not correct. So the maximum LIS for at the 6th index, that is only for 101, can be only like 1. We can only choose an array element of 101, or we can only choose 18. Either of these. We can't take both because of the non-increasing order. So again, it would be 1. Now let's go to 7. If I choose this 7, 101 and 18, now we see that 7 is less than 101 as well as 7 is less than 18. So one of the possible sequences that we choose this 7 and 101, which will be giving me 2. And similarly, I can also choose 7 and 18, which is again 2. So now we can see we are actually seeing a pattern here that we are only including the next element only if the current element is less than it. If it's greater than it, we have to exclude that subsequence element and move to the next. So say just for LIS 5, I can see that it can be max of at least 1 if I just choose this element as 1, so it would be 1. And then I will include the next element, LIS 6, only when this is less than this. 7 is less than 101. So we can choose this. So it means that it should be LIS if, we can also like a pseudo algorithm here that if LIS of 5, the current element is less than LIS of 6, then it would be then use including 1 plus whatever we have already computed at LIS 6. We have LIS 6. That's a benefit of using dynamic programming, that we have already chosen that what is the longest increasing subsequence starting at index 6 as 1 here. So we can use 1 plus whatever is there at LIS 6 when the condition is LIS 5 is less than LIS 6. So it would be 1, then 1 plus LIS of 6. Similarly, 5 is LIS of 5 is less than LIS of 7. So the same condition goes here. If LIS, so we are just seeing this pattern, and this is how we are approaching this problem. We've tried to find an optimal structure, a way that we can write it into an algo form, and we can use the previous subproblems that we have already solved. So this is what we are doing right now. We are actually coming to this type of algo, and we are reusing, let's say, LIS 6, which we have already computed, and similarly for LIS 7 as well. So in this case, again, the formula goes same, that if LIS 5 is less than LIS of 7, then 1 plus LIS of 7. Okay, so we already checked this, that it's 1 plus 1 is equal to 2, or 1 plus 1 is equal to 2 in the second condition. So either way we can choose these. So this is the number 2 right now. Now again, just use the same formula for the other elements, LIS 4. So it should be, if I just take the max right now, I just write the formula directly here. It should be FIX1, or now we check that again, 3 is less than 7, 3 is less than 101, 3 is less than 18. So we can choose all of them. And if I choose all of them, then it should be, let's write it down first. So it should be 1 plus LIS of 5. Okay, and 1 plus LIS of 6. 1 plus LIS of 7. So we already seen that 2 is the maximum. So 1 plus LIS of 5 would be the maximum of all this. So it should be 3. Now similarly doing it for each of the other elements. So LIS 3, this 5. Now 5 is not less than 3. So it means that we cannot include this. But 5 is less than 7, 101 and 18. So we can use only like 1 plus LIS 5 and LIS 6 and LIS 7. So it should be, because we can't include this, maximum is 2 here. So essentially it would be the same formula as here. Because once again, LIS of 3, that is 5, is greater than 3. So we can't include in an increasing subsequence, we can't use 5 and 3 both. We can only use 5, 7, 501, or 518. So here it would be again this formula. So it means that the value should be 3. Now LIS 2, now 2 is less than all the other elements which are next to it. So it would be the maximum of whatever the next sequence is there. So we can just see the formula can be including this LIS 5, 1 plus LIS 3, 1 plus LIS 4, everything. So it would be giving me 4, because 3 plus 1 is 4. Now, okay, I just marked it as this. Okay. Now 9 is only less than 101 and 18. We can't include index 2, 3, 4, 5 because 9 is greater than all of these elements. So again, the formula would be same as what we have used LIS 5 here, which is this one, and it should be 2. Now similarly, for the last element 10, it would be 10 is only less than LIS of 6 and 7. So again, it would be 2. So this is how we have broke down this problem as a bottom-up approach, starting from the base element as 1. And then we keep on going back and trying to find out all those sub-problem solution by reusing the solutions we have already found in the next array element. So, so again, just to reiterate the formula, for each, we start with the bottom-up approach, and for each of the element, we only include the next element if the current element is less than the next element. If it's greater than that, we just discard that, and this is how we proceeded until we reach to the last index. Now, once we have got all this LIS values, I mean, I already highlighted it as 4 is the maximum number. So this is our answer. So yeah, this we need to just once we have this array, we need a very simple for loop to find that what is the maximum number in this LIS, and this is our final answer.